All right, so we're going to talk about QML and C++ and how they can work together. As I mentioned, these notes are actually a reduction of about a 3-day course in how to write applications in QML and Qt. So a lot of things have been compressed, condensed, and some things dropped. I was looking through the notes, and one thing that actually got dropped is a nice, quick, and dirty way of exporting C++ instanced objects into the QML environment. So if everyone doesn't mind, I'm actually going to switch gears for a second and jump into the notes for my presentation tomorrow. And we're going to go over the little short section about how if you make an object in C++, like you make a new something pointer, you can export that something pointer into QML. These notes are really geared toward creating an item that you make a pie chart or bar chart item in QML, and the back end of that item it actually does its drawing in C++, which is also very useful. So let's go ahead, and if people want to give me your business card after the notes, after the class, I can send you these notes as well. I think you already have these notes I've been going over on those USB sticks. If you don't have the notes, likewise, I can send them to you as well. They're actually an open source Nokia thing. So you can take objects that you instantiate in C++ and export them into the QML execution environment, where they will just appear as, well, magic variables. So you can make an abstract item model pointer and export it. You can make a QObject pointer and just export it. And the other way is you can actually export types that are instantiable in QML. So there's a slight difference there. So things that you can make in C++, say you make them in main, and then you can export them into QML, is you can make any QObject pointer. You can create it in C++ and export it into the QML environment. Properties simply become variables. Slots are functions. Now, sometimes when you're designing your C++, so it can be used in C++ and QML, there are some things like functions with return types that you generally don't want to be slots, but you want them to be invocable from QML. So you can use the QInvocable macro in front of the signature rather than putting it in a slots section. You can export a QList of QObjects, and this can be used as a quick and dirty data model. However, you can't insert or append onto the list. It's just a quick and dirty list of items. And the most powerful thing that you can make and export from C++ is an abstract item model pointer. You can create that, create all your data in C++, create the interface to your data in C++, and simply export it into QML and use it there. You can also export any QVariant instance, which is a wrapper, basically a glorified void star, and it becomes a simple value type in QML. This is probably the rarest thing to export. Yes?
If you export that in a custom variant where you've done the registration in C++, does that transfer?
Yes.
As well?
Yeah, well, it turns out the problem with variants is that you can only convert them to and from your particular item. And if, since in QML you can't do a conversion to from a custom item to a string, you can really only pass it in and then pass it back to C++ to have it processed. If you want to have an item, a struct exported, where you have my variable dot name, my variable dot title, it needs to be a QObject pointer. So it has to have a two-string. Yeah, but that's the trick. And even in C++ Qt, you can't override two-string for complex types.
Right, so there are quite a few variants that you can't use inside of QML because there is no string.
Yes. So what you're going to do is, and there's actually an example a few slides away, where if you need to wrap something like something that works invariant in C++, and you can convert it back and forth. It's a deep data structure. You can wrap that in a Q object and pass it out. So, but we're going to be concentrating on Q object pointer and abstract item model. So, so here we have a binding where we're binding our rotation to some value, a min and a max. These could be variables that are instanced or properties in QML, or they could be things that have been pushed from C++. So QML can call back to C++ by simply calling the functions that are slots or use Q invocable. So you can say backend.go do something. So here's how you would make, say, a car object. And a car object has a list of sensors, can get a sensor value, units, a min and a max. So the key here is we have the Q objects, Q object macro, we use Q enums, and we have a sensor. And this is good C++ so far. Now, the problem with good C++ and QML is there can be some clashes. One is QML does not like enums at all, especially when you're exporting the instance without the type. There's a way to use enums when you export the type, but when you're exporting an instance, it's a lot harder. But you can use a wrapper object. Such as here, what I'm really going to export into QML is this car sensor proxy, who has a bunch of Q properties. This is a flyweight object. It is going to, in its constructor, take in a pointer to a car and the sensor it's going to watch. And then our interface is going to be a simple property value min and max. In C++, we are going to create our declarative view, which is going to give us the engine that the QML is going to run inside of, as well as the window it's going to run in. And we set the source. Here I've got a project called Megadash, which is going to be a dashboard for my car. And we can show it and we can exec it. Now, what happens here in this comment where it says export C++ instances here? See next slide. Well, between creating your view and setting the source, you can export as many objects as you want, such as in a giant for loop, export 100 sensors. So here I'm iterating over the car's enum for its car sensor, and I'm making car sensor proxy pointers. And we give it the car and the sensor, and then we are exporting into the view. You get the view's root context, and you export context property. Probably one of the most ambiguously named functions in Qt. But this will export a C++ instanced object into the execution engine. The first parameter is a string, which is the name of the variable that's going to be used in QML. Since I use a for loop here, my car is smart enough to return me a string that represents the name for that particular sensor. And we export a name and the actual pointer. So now magically, in my application, I have RPM, speed, fuel pressure, oil pressure. Not only that, but we can get oil pressure dot minimum, oil pressure dot maximum, oil pressure dot value. Okay. So I'm basically using a way of just taking things that I allocate in C++, I control the life cycle of, and pushing them into the QML execution engine. The only rule is that for the lifetime of the view, these objects need to exist, or you're going to get seg faults. Makes sense, right? So that is a nice, quick, and dirty way of taking, and even appropriate in some cases, where you're going to take data, especially data models that you have in C++, and you're just going to export them into the QML runtime environment. Maybe this is some tabular data that you have that's going to run like a pie chart or something, where you're reading things off of a serial port or off of a network. Any questions? So we'll go back into the regular notes, even though I also talk about it, is how to export types. So rather than having instances that we push into QML, I want to say, I'm going to make my own type of item, maybe called a car. And we're going to let QML programmers make an instance of car, where car's implementation is in C++. And we're going to do that. And we're actually going to do that with an ellipse item. I mentioned that there's no ellipse or circle item in QML, but we could make our own. And we could have it drawn and managed in C++. So anytime you want to write C++ code that is going to know about the declarative environment, there is a separate Qt module called Qt declarative. So in your project file, you need to have Qt plus equals declarative, and you need to pound include things from the Qt declarative module. Oftentimes, there's so few header files, you could just use the magic pound include Qt declarative and get them all. So here's an example where we are including the Qt declarative view. And just like in the example we saw, we make a declarative view and we set the source on it, we show our window, and we exec. So every view that you make is a new runtime environment. So you probably want to make as few of these as possible. Inside of your project file, you want to use Qt plus equals declarative. Now, from when it comes to resources, your QML can actually be stored in the Qt resources. So that when you say, set source here is QRC, files, animation.qml. This is coming from the resources. And remember that everything is relative to the location of the QML file that you are running. So the contents of animation.qml is going to use all relative pathing. And that's going to be relative into the resource file. So you're going to include all of your QML code into the resource, and then you can have just distribute the executable and not have to worry about this whole pile of QML files to distribute along with your executable. Yes? Yes. Yeah, that's true. So there is a way to break the rule. For main.qml, the root item, you could call it, does not need to start with a capital letter. And sometimes you'll see it in some people's projects start with just main.qml has the entry point with a lowercase m. But for all other files that need to be loaded by QML, they need to start with a capital letter. So to create a new instantiable type, you can either inherit from directly QObject, or you can use QDeclarativeItem. If you want to draw onto the screen, you need to use QDeclarativeItem, which maps pretty much directly to the item in QML. If you just want to be a hunk of data that people are going to instance and pass around, then you can be just fine inheriting from straight QObject and skipping the overhead. So basically what's going to happen is you're going to register this type to be valid in QML. And we'll see what that means in a minute. Let's take, for example, first this ellipse1.qml file. Now, there is no ellipse item in QML. We're going to make that in C++ and let users use it. So here we have an import shapes 1.0. We have this new module called shapes. And inside of shapes happens to be the ellipse item. And we create it just like any other QML item. From the point of view of this file, the user does not know if ellipse is another QML file or whether it's one of these C++ plugins. So it's very clean from an API standpoint. And the ellipse is just going to draw the little ellipse on the right. It's pretty basic. So how do we make this item that can have a width and a height and be drawn in QML? Well, we simply include QDeclarativeItem and inherit from it. We use the QObject macro that's going to be required. And we implement the constructor that takes in a QDeclarativeItem parent. This is going to be used by QML to assign you parentage. Just like you do for QObjects and QWidgets, there's going to be parent-child hierarchy. We've already used that. Then you need to implement the paint function. So this is actually maps one-to-one and actually up above of QDeclarativeItem inherits QGraphicsViewItem. And QGraphicsItem has the paint method that takes in a painter, a QStyleOptionGraphicsItem, and a widget pointer, which is the widget you're being drawn on. So the implementation is actually pretty easy. We have a simple constructor. We pass our parent up to our superclass. And we need to have this set flag. By default, items are not drawn. If you want to be drawn on the screen, you need to set this flag, graphics item. Item has no contents to false. Why it's not the default to be drawing on the screen, I'm not sure. But it's what you have to do. In its paint function, we do something super basic. We take that QPainter pointer that we've been passed, and QPainter, as you might know from the C++ API, has a drawEllipse function, which takes in a rectangle. And we're going to take in our OptionRect, which specifies the rectangle of the screen that we take up. So whatever space we've been allocated, we're going to try to draw an ellipse that is going to inscribe that rectangle. Yeah. Well, you can imagine if you're a root item. Maybe somebody starts a QML file with ellipse, open bracket. You have no parent. No, your parent is another QDeclarativeItem. Right. The widget that you get passed in the paint function is pretty much useless. It's really there because it's useful when you're doing QGraphicsView programming. And you're inheriting from QGraphicsView here. Be a little forward declaration. In QML 2.0, this particular API is changing. But if you use QDeclarativeItem, you can actually get the same function names and syntax by using cute, quick, painted item. So there is an upgrade path, but there will be no QDeclarativeItem anymore. And that will change in Qt 5. All right. So, yeah. What we have in main, instead of exporting a C++ instance of something, we're actually using this macro function, QML register type, to register a type into the QML runtime. And we are exporting the ellipse item class. And we're putting it in the shapes module, major version 1, minor version 0. And the name of this item is going to be ellipse. Notice that the names don't have to match. We then go ahead and make our view. We set our source. And now the code that uses the ellipse item is going to work, because now ellipse is a valid type. When you make an instance of ellipse, it's actually going to make an instance of ellipse item. Yep, it's kind of the beauty part of it.
Is it going to tie visible
Well, since you are basically by inheriting QDeclarative item, you're inheriting item. Remember that item that is the generic base class for everything? That's basically what you're inheriting. So you get X and Y and visible and opacity and all of those properties of item you inherit. Just like when you inherit from C++ from a Q object with properties, you inherit all their properties too. So from the client side's perspective, whoever's writing that QML never knows what's implemented in C++ and what's implemented in QML. And that's a good thing. It's not any different. So even if you wrote some QML and you had this fancy game board object and you found that it wasn't fast enough doing it in JavaScript, well, you could make game board in C++ and export it as game board, and your game board code would still work. So do note here that we are registering these with the fully qualified imports. So this is import shapes 1.0. There's no way to do this without having the module and the version. And we are effectively a subtype of item. So here, for example, we have the ellipse item. And we want to add a property. We want to add a property to our ellipse to have a color. So we want to fill it here with the color blue. The x, y, width, and height we got from inheriting item. Easy. But we need to add color. Luckily, adding color is as simple as adding the QProperty macro. We need a read function, a write function, and a notify signal. So you would make your C++ as usual, meaning that you're going to have a member for your color, you're going to have a set color and a color getter, and you're going to have a signal for color changed. This is as normal, as cute as you can get. Then at your header file, you simply use the QProperty macro. You specify the type of this property, which is QColor, a name, which is simply color, a read function, called color, a write function called setColor, and a notify signal called color changed. This is an opportunity that you don't have in straight QML, is that you can make read-only properties by manipulating the QProperty macro. So if you didn't have a write function, then you would be read-only. And if someone tried to set your value, the QML runtime would complain and say that is a read-only property. Also, some properties aren't dynamic, so there's no reason to have a notification signal. In that case, you can replace notify with constant, and you don't need to specify a signal. That tells the QML environment never to expect a signal when this changes. Often useful when you want to have read-only constants exposed as properties. So it's pretty simple when you, in C++, just like if you were writing graphics items or you were writing widgets, in your sets, you should always make sure that what you're being set to is different than what you already are. That will keep you from getting infinite recursion if you have signals and slots crossed up. And you set your color. You call update to repaint yourself. And you emit the correct signal. And here we have the signal color changed. And now all of this code basically equates to the color property in QML. And likewise, since it's a real property, there's an onColorChanged signal handler that you could implement.
Why isn't your element Ellipse the same as your object name Ellipse item in C++?
That's a good question. I guess no reason in particular. It could have been called Ellipse.
How does it know that object?
Good question. So the main, when we exported it, we did this QML register type, which takes in a string name to use for the type name, and which does not have to be the same as the class name. What's that? It is a template. It is a template. Now, the nice thing about Qt in general is that Qt uses templates, here, there, and all over the place, but it doesn't really force you to write template classes, which is nice. But this is an example. It's a template function. It takes in a type, and it does its magic. All right. So then in your paint method, which is going to be called, just like in widgets or in graphics view, is going to be called anytime you call update. Now it gets a little more complicated because we can't simply draw the ellipse. We're going to save our painter state. We're going to set the pen. We're going to set the brush. We're going to draw the ellipse and restore the painter state. It is always polite to save and restore the painter state anytime somebody passes you a QPainter pointer. It would be rather rude if you changed the contents of somebody else's pointer when your function returns. So in summary, we've seen that we can create a new type with QML register type. We can make a new visual item with Qt declarative item, and we can add some Qt properties. Does anybody have any questions on this? We're going to move on to functions and slots and fun things like enums. Yes? Yeah, in fact, you can have a parameter. Most times in C++, you would have as a parameter the new color. QML will always ignore the parameter. So it's like one of those things in Qt, you can always drop parameters from signal to slot. So when that signal, when the on property changed, it's going to be a signal with no parameters. It just wants to know that it needs to rerun all of the evaluations.
Question. Could you multiply derive from Q declarative item and a complex widget, Q table widget?
Oh, no. But what you can do, and this will get you a little further, is that you could inherit from Q declarative item, okay? And you can, well, actually, you could inherit from Q proxy widget. And you can actually wrap your Qt widget in Q proxy widget, which is a Q graphics item. And you can find examples of that online. Be warned, just like when doing graphics view programming, Q proxy widget has performance problems. So if you try to take that QML screen that has an embedded Q table in it and you try to animate it, it's probably going to drop in performance. But you can do it. In fact, we've done that at ICS for some projects that wanted to use like QWT chart to do some line graphing.
So let's say you have multiple properties.
Yep.
And you notify whenever you update properties, you have to signal it, right?
Yep.
So I can use just one signal for multiple properties. Is that going to make any performance problem? Is it better to use multiple signals?
It is better to use multiple signals because, unless they are intrinsically related, because it is going to, when that signal fires, QML is going to rerun all bindings that include that property. So if you change one property, but you just have this uber everything change signal that's attached to 4 different properties, then QML is going to seek out those 4 properties and rerun all the expressions in the bindings. As opposed to if one really changed, you can get just maybe 2 of the lines instead of 20 lines to be recalculated. So So that's the downside there. So now we want to add functions. Oh, actually, we want to add signals to our Qt class that we're exporting into QML. So basically what we want to have is we want to have the ellipse have a ready signal, and so we can use the onReady signal handler. Ready in this context doesn't really mean anything. There's no, it's not like QML and Qt are running in separate threads, and there's some synchronization that needs to go on. This is just an example, just some state that's changing. So, and what we want to do is when something's ready, we want to change some text label to say ready. Very simple. And all you need to do in Qt is do what you would normally do. Just declare a signal. Ready, just like you did color changed. The meta objects will take everything from there. You just recompile your program. And of course, you need to emit the signal. But after you implement a signal, this code will run whenever you emit ready. So for example, we have a QTimer single shot. Just for giggles, after 2 seconds, we're going to emit the signal ready. So at some point, the signal is going to get emitted. OnReady is going to be called, and we have stuff happening in QML because we have emitted signals. So when people ask me, how do I manipulate the QML items from C++, what you really want to do from a design perspective is not find the items and manipulate them, but you want to design your backend to emit the right signals, that state has changed, and let the user interface decide what that change in state means for the user interface. So if we want to add callbacks, basically we want slots that we can call from QML. It is just as easy as making slots in C++. You have your option. So here, when the mouse area is clicked, we want to actually call setColor on our object with the string of a color. So what we can do is we can have this new slot called setColor. And you'll notice that it takes in a Q color. Now, the nice thing about QColor is that it has an implicit conversion from strings. So we can pass it dark green, and when it gets called in C++, dark green will be passed to the implicit copy constructor for QColor, and we will make a color from, quote, dark green. So you have your option of specifying public slots or using the QInvocable macro. Which one do I prefer? Yeah. So for things that should be slots, like as an experienced Qt programmer, you'll know what should be slots. Like things like setColor is a good candidate for a slot. Something where you're doing like a function that's going to return a value is not a good candidate for a slot. But it might be a good candidate for something to be called from QML, like get me some value. In that case, I would use get me some value with QInvocable in front of it before someone thinks that they can connect a regular C++ signal to this thing and being like, what is the deal with this function? So we can also We can also add methods using the Q invocable, such as the random color method here, where we're setting our parent's color to parent random color. Parent is an ellipse, so the storage for color is in C++, and we're using a function that returns a type. So here, random color is not really something that's useful as a slot. We use the Q invocable macro, and we say return a Q color and random color. Done. Now the meta object system is going to find that macro, add it to the list of callable functions, and it now appears in QML. So this line will run. On-clicked parent colors, random color. And random color here is implemented as some random color, actually. There's nothing really to say about that. So we figured out that we can define signals just like we do in C++, and they're usable by QML. We can define slots just like we do in C++, usable by QML. And we can define functions and give them the Q invocable macro, and they're usable from QML. Any questions so far? So defining custom property types. So you can guess that things like float and Boolean and string and colors work. But what if we wanted something more complicated, like another item or another Q object that's deep and has many properties? Or maybe we want to use enums from C++. For example, we want to make our ellipse take a style property, where style is an enum, such as outline. So you'll see these sprinkled all over the Qt quick stuff, where you can say text dot something. You can make your own ellipse dot something, which is an enum. And this is actually pretty easy, because all you need to use is a Q property macro and the Q enums macro. This is actually an old macro, goes back, decade, maybe longer. It was actually used in designer plugins. It's how a designer would know that when you had in your property tree that this is a, what style do I want my frame to be drawn in, it actually got its strings to display from this Q enums macro. What it does is the meta object compiler is going to read your header file and go looking for an enum called style. It is then going to make a map of the string name of the enum to the constant integer, and keep that map so you can convert to and from string. And that's the same exact functionality that QML uses to convert your outline and filled to ellipse.outline and ellipse.filled. These aren't 0 and 1, they're actual strings. So once you use the QEnums macro, you can use QEnums, style has a type in a Q property macro, and this just works. You just need to have a style and a set style, some storage, and a signal. And just like in C++, just like we set the color, all you need is a getter and setter, and make sure your setter calls update and emits the right signal. Very similar to the way we did the color, except now we have an enum. So maybe enum isn't specific enough. Maybe we want to trade in other declarative items. We want to set our style by passing an instance of a style class, which is another class that we're going to export. So like you can make instances of ellipse, you can make an instance of a style, where style is a non-visual item. It's just a collection of data. So how could we do this? Well, it's a little more complicated. We're apparently also up to shapes 7.0. But what you can do is we declare another QDeclarative item. And this time we're going to leave the default to not draw itself because this is just data. And we're going to implement two properties, color and filled. And we implement that just like the ellipse. So we're making a style class and an ellipse class. And then we're going to have a style and a set style. Now, what makes this interesting and different from C++ programming is that we are passing pointers here, and we're taking pointers. So generally in C++, you would return a copy and you take a constant reference. This is going to deal in pointers. And our Q property is going to be of type style pointer. And the name is going to be style. Read is style, write is set style, and notify is style changed. So when we do this, we can actually modify our paint to actually use the style and decide whether you're going to be filled and what color you're going to be based on the contents of that style object. So what we need to do is we need to register in main not one type but two types, the style type and the ellipse item. And once we do that amount of work, this code is actually going to work. Yes?
Since the style is not a visual item, could that have been just a Q object instead of a Q declarative item?
I think it could be. Yeah. Yeah, it could be, yeah. Yep. Good question. Now you're getting into religious wars. So according to purists, the type is the type, and the fact that it is a pointer actually belongs to the name of the variable. Because if you use the comma notation, I know this is a function declaration, but if you were making variables and you said style, star, name, comma, something else, so you made two instances in one line, then what that would actually make is not two pointers, but one thing that's a pointer and another thing that's an actual stack instance. So some people like to put the star after type space star, then the object. It's really a style thing. I prefer to have the star after the type, and I don't put two things in one line. Good question. I'm not actually sure on that. What's that? Oh, is it required that the star go to the on style? Yeah. And I'm not sure on that actually. That is a good question. Yeah. Or if it would take it either way. I'll have to look into that. Yeah. So another question is, okay, maybe I want to have a property that is actually a list. So just like we had an array of styles and an array of transitions. Maybe I want to have a chart object, and that chart object has a list of bars. So how would we do this from C++? Well, it's pretty easy because we have a special type of property that is going to be a QDeclarative list property. So here we are going to use the QProperty syntax where our type is actually going to be a template, which is QDeclarative list property, and we give it the type of which this list will contain. And it's going to be called bars, it's read functions bars, and it has a notify bars changed. And what we're going to find out here is that in reality, our bars is going to be read-write even though we don't have a write function. And the reason for that is that the read function returns the list, not the contents of the list. So we can manipulate the list after we get the reference from the read function. So,
Back to the question of style of two objects supposed to be declarative, and what would you want to clarify?
yeah.
If you do that, the only code change besides where it's derived from all that, when you set the style in the Ellipse item, you no longer set parent item to this.
OK.
Okay, does that imply, remember, from the object point of view, it doesn't have a name. Does it need that in order to destruct itself properly?
Yeah, I don't think so because the items themselves need to be destroyed by QML. Because imagine if the situation where you set 3 styles in a row, or you keep changing the style because you keep clicking on it. Like you can't let them just sit out on the heap waiting for their parent to die. That would be at the end of the application. So that suggests that it's doing the management on, after you set it, it would delete it. Yeah. And that's going to be required for grep. Yeah. So we make this chart item, which is going to use our bar items. And we have this queue list of bar item pointers. And we are going to have a static append bar function, which is going to take in the list to append to and the bar item to append. So, and then in our function bars, which is our read function, we are simply going to go ahead and return a QDeclarative list property. And the QDeclarative list property is a little complicated because it is a template, so it takes in the type of which it contains. It takes in a pointer to the as a parent, and it takes in a function pointer to append to. So that's how it's going to know that when you call bar, 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 how it's going to append, append, append onto the list. So in append bar, what we do is we set the parent correctly so that we're going to take possession of this item so we can arrange it correctly. We're going to append onto our bars object, and we're going to emit bars changed. So what we've seen is a way to make QDeclarative items that can be instanced and seen on the screen like the ellipse. We've seen how we can export properties in enums. We've seen how we can export sub-items. So our ellipse had a style item. We've also seen how we can have our visual item have other visual items and manage them in a list, like our chart had a list of bars. Using the QDeclarative property, which is a fairly complicated thing and needs the function pointer to append onto, but is generally using the same QProperty syntax as everything else. So the final thing that we're going to talk about is how to take your C++ items and put them into a module. So just like we had the line item module, we're going to make our shapes module, where instead of exporting the types from main, we're going to let some shared object take care of that. And just like Qt scans certain directories and gets all the SQL drivers and all the image drivers, it is going to scan certain directories and find your QML C++ plugins. So what you can do, much like every other plugin in Qt, you can simply inherit from QDeclarative extension plugin. Same idea as QImage format plugin or QSQL driver plugin. And it needs to use the QObject macro and needs to implement one function called register types. And what happens in register types is, well, what you used to have in main. So you'll have a QML register type ellipse item. You're going to be passed your URI. The reason why this is passed in is because the QML dir manifest is going to define that. And where you're located in the file system is going to define what the name of your package is. You specify the version. Here we're up to 9.0. And we have the name of the item is going to be ellipse. Now, to be entirely accurate, we should really have two registers. We should register ellipse item and register our style item. And we have to use the magic export plugin 2. Just like every other plugin, this is going to expand to some C symbols that Qt is going to use to go fishing in the shared object to get your entry point to call register types. So you want to build this as a shared library. So you can use something along the lines of this project file. We have a template of library. We need to tell the config variable that we're a Qt plugin. We need to use headers and sources, of course, and possibly a dester to drop our shared object somewhere that's useful. So we get back to this thing where we have a plugins directory and maybe a standalone directory. And we have this QML dir. So this QML dir is a manifest. And we saw that QML dir can specify QML files. We can also specify shared object plugins to load when you load this import. And the way you do that is you specify an extra line in your QML dir that says plugin. Ellipse plugin, that's the name of the shared object without the .so at the end, and the directory to find that shared object in, which is a relative path. So it could be in this case, .. plugins. It could be in relative path plugins. So in one QML dir file, you can have a bunch of QML files and one or more C++ plugins. And to the user who imports that package, they're never quite sure if what's implemented in QML and what's in C++. It looks all the same to them. So here's an example here of using the ellipse. And if the QML dir and ellipse 9 are in the same directory, then there's no need to you don't need to import your own module, is pretty much the point of this slide. Because item 9s is actually a QML file that's being distributed with our plugin. So you can either load these plugins yourself using the Q plugin loader, or you can simply manipulate the QML import path by manipulating static functions on Q application or setting the QML import path environment variable. So the extensions that you write in C++ can be compiled into plugins. They can be bundled with other QML files, and they can be imported as one gigantic package. If you manipulate the QML import path or use the -i flag to QML viewer, then QML viewer will find these items. So you don't need to have a C++ wrapper. If you use plugins, you can actually get C++ code to be run from QML viewer, which is kind of cool. You can load the plugins directly using Q plugin loader, or you can let Qt automatically load the plugins using QML import path. And that brings us to the end of my presentation.